Well, good afternoon, everyone. Welcome to Nisshinbo Audio Innovation Challenge, powered by ACE. My name is Jeremy Lim, and I'm here with my colleague Rebecca to run this innovation webinar together with our ecosystem partner, Nisshinbo. Today, I will be doing the program introduction before I ask our partners, Nisshinbo, to share more about their company as well as their technology. Following that, we'll be doing something like a fireside chat and to talk more about the challenge. And then lastly, we'll be opening up the floor to the audiences to ask more questions. Do note that we will be asking and requesting our audiences to type out any questions that they have. My colleague Rebecca will be moderating the questions that come from the floor. So I think as many of you may know, Nisshinbo is an audio chip supplier to Amazon's Echo and also to other types of devices. In this innovation challenge, Nisshinbo is looking to collaborate with startups that are in the healthcare and security industry. But it's also to be noted they are also open to other industries. And through this challenge, winning participants will also be able to get a cash prize. And more importantly, the chosen participants will also be able to do a R&D collaboration with Nisshinbo's engineers to improve their product's functionality and competitiveness. Going briefly into the entire innovation program journey. So startups and SMEs application have been open since the 22nd of February, and it will end on the 26th of March, 2021. Now, Nisshinbo and ACE will also be selecting the finalists, and we will release the results roughly on the 2nd of April. And the presentation day will be held on the 12th of April, 2021. When it comes to the criteria of choosing the finalists and the winners of the Innovation Challenge, Nisshinbo is looking at 4 main criteria. The first one is the degree of problem statement fit. Second one, the company sustainability. Third one, technology differentiation. And fourthly, the business model and target market. Now, if your solution is not part of the problem statement outlined by Nisshinbo, do really kindly note that Nisshinbo is really open to all suggestions and solutions proposed. Now, I would like to pass the time to Fuji-san to share more about our company, Nisshinbo. Fuji-san, please.
Okay, thank you, Jeremy. Hi, very good afternoon to you. I'm Fuji from Nisshinbo, Singapore, and I'm going to introduce our group profile to you. Before that, let me talk a little about sound. You may know that some sounds are audible and some are inaudible. When it comes to sound, audible and sound, I think you can imagine the sounds you hear will not be same to your grandfather or grandmother or to your pet dog. Next, please. No matter how loud I spoke to my grandfather, he repeated for asking me, "Pardon, what did you say?" when I was a child. Well, have you ever thought about how you can hear inaudible sound and what inaudible sound mean? The next slide. The human ear generally hears sound in the range of 20 Hz to 20 kHz. Sound above 20 kHz are called ultrasound, and that are inaudible to the human ear. According to research, dolphins and bats can hear 6 to 7 times higher sound than humans and use them to communicate with each other, find food, and fly, avoiding hitting in the darkness. Ultrasound has various potential in people's lives as well. Familiar examples are ultrasound echo enabled to see inside body, and fish finder is also using ultrasound to find fish in the water. The details of ultrasound will be shown in the next technology instruction. Nisshinbo's sound chip called MEMS microphone detects sounds from several hertz to 100 kilohertz. MEMS stands for Micro Electromechanical System. This sensor can collect not only audible sounds for humans, but also sound that can only be heard by bats and dolphins. Later, Mr. Fujiwara will tell you more about the technical aspect. Let me emphasize our direction in this challenge is to utilize sound for people's well-being. Go to the next slide, please. It may be a sound from the human body that cannot be easily heard, or it may be an environmental sound that is usually heard casually. We want to catch those sounds with our small chips and create people's better lives. Let me introduce our company briefly. Nisshinbo is a Japanese manufacturer started as a cotton spinning company and providing service for over 100 years. We expanded our business from textile to friction material for automotive brake, precision instruments, and chemical products. Since the beginning of 2000, in anticipation of the globalization and rapidly expanding information society, the core business has shifted to electronics by multiple M&A. Therefore, as you are seeing in the sales chart, Nisshinbo is a now company of electronics. Nisshinbo Singapore is 100% owned by Nisshinbo Holdings, and our mission in here is to create new business starting from Singapore. Although we have many kinds of business, we clearly define three strategic domains. The first is mobility. This includes mobility for all ground, maritime, and aviation. Our vision of this segment is achieving advanced and safety traffic for everyone. We use our core technologies, such as radars and IC chips, to realize advanced and safe traffic. We are also actively working on the development of electronic devices and collaboration with various manufacturers, which are necessary for autonomous operation in the future. As shown in the chart, infrastructure and safety also utilizes wireless and electronic technologies to support people's safe lives through disaster prevention and mitigation. One example is weather radar. This radar helps minimize disasters and encourage people to evacuate by detecting torrential rains quickly and accurately. And we also have equipment for inspection of buildings and facilities without distraction, using our radar technology and contribute to environmental safety. Safety and sustainability is our goal of this domain. In life and healthcare, we aim to provide people's healthy and delightful lives by digital technologies. Recently, we have been actively developing a smart textile as a collaboration between textile and IoT technologies. Smart textile, let's say, working clothes that make conversation easier to hear in a noisy workplace. Another example is a maternity bag mentioned in the website on this challenge. Within this strategic business domain, we have many customers not only in Japan but also overseas. We have a long record of success in providing to many customers, such as automotive, home appliance, and smartphone manufacturers globally. Our micro device sector, which produce and develop MEMS microphones, has been led by New Japan Radio Company Limited, which has a long and solid track record for over 60 years. The strength of New Japan Radio is its design, process, and packaging technology. ICs and semiconductors are now necessary for all electronic devices, including smartphones, automobiles, and home appliances. Our technology can provide ICs that require precise design as a module in the smallest size. They would be indispensable in the future of accelerating digitalization. We would like to collaborate with the startups making the most of our MEMS microphones and would like to make people's lives better. The chip is amazingly small. They are actually mounted on smart speakers like Amazon Echo Dot and smartphones as well. We provide our sensor to partners with great idea and support POC. And we hope that our sensors will be utilized in solving social issues, such as problems are clear, but there is no way to solve them, or market demands are high, but suitable sensors cannot be found. Of course, we welcome any incredible, unique ideas. Mr. Fujiwara, who is the next speaker and the head of the development group, supports from Japan. There is our R&D center in Saitama Prefecture. And business development will be supported by the Singapore team, including myself. In order for this light and tiny sound chip to bring great happiness to people's lives, Nisshinbo Group are willing to carry out co-creation with startups. We are very much looking forward to collaborating with startups in the world to create a new business. Thank you for listening.
Yeah, so thank you very much, Fuji-san, for sharing so much about Nisshinbo. So next, I'll be asking Fujiwara-san to share more about the MEMS microphone technology itself. So I'll be passing the time to Fujiwara-san.
Thank you for giving us this opportunity to introduce our cutting-edge technology from New Japan Radio. Hello, we are R&D department at NJR, a semiconductor manufacturer based in Tokyo. Today, we are going to introduce our acoustic sensor. New Japan Radio has two major businesses, the semiconductor business and the microwave business. We are talking of the semiconductor business in this presentation. As a part of it, we mass produce these MEMS microphones to be set in mobile phones and many other devices. Its production volume accumulated so far exceeds 400 million pieces. This slide describes the MEMS microphone. The picture on the upper left is a diagram of a packaged MEMS microphone module. The object in its center is a block diagram. In the chart below is an image of the signal flow. Please take a look at these. The MEMS microphone module consists of two parts, a transducer and an ASIC, amplifier circuit. First, the transducer converts an external acoustic signal into an electrical signal. Next, the ASIC converts the impedance, amplifies the outputs and the sound. At this point, the ASIC generates a high voltage for the transducer. Next, let me explain sample devices we can offer. We can provide the following 6 types of samples. From top left, 1. Acoustic sensor module chip. 2. Array sensor. 3. Vital sensor. 4. Acoustic sensor. 5. Dust-proof and waterproof sensor. 6. Non-contact sensor. 1. Acoustic sensor module chip is a sensor module chip component that can sense ultrasonic waves. The size is length 4.25, width 3.55, height 1.10 millimeter. 2. RA sensor can detect the direction the signal comes from. This photo shows 2x2 array, but 3x3 array is also available. For example, an ultrasonic sensor on a car bumper only detects the presence or absence of an object. However, if you use this for the sound receiving part, you can detect the direction of the object. 3. Vital sensors can detect the sounds of the human body, such as heart beating or breathing sounds. This is not a chip part, but a case, so it is easy to use as a vital sensor. 4. The acoustic sensor is easy to use by putting one acoustic sensor module chip in a stainless case. It can be contact and non-contact sensing. It can also be used to measure predictive maintenance, such as ultrasonic measurements of motors. I will explain about predictive maintenance later. 5. Dust-proof and waterproof sensor is a product with one acoustic sensor chip inside. This outer case makes it free from dust and water. 6. Non-contact sensor also has one acoustic sensor chip inside. It senses without contact. Next, we would like to introduce potential usability of these devices. We set 3 items as our strategic business domains: mobility, infrastructure and safety, and life and healthcare. We will utilize acoustic sensors to solve the problems in these 3 business fields. We will introduce the applications of acoustic sensors in each area. For mobility, the sensor is used to detect people or obstacles on the road and driver's voice as a speech recognition system. For infrastructure and safety, the sensor is used for predictive maintenance and tapping sound inspection in non-defective product discrimination tests. For life and healthcare, the sensor is used for watching patients in hospitals and nursing facilities, electronic stethoscopes with noise cancellation, watching for the elderly living alone, and so on. Before introducing some of the examples where our acoustic sensor works, I would like to explain about the wave and frequency. People can hear the waves from 20 Hz to 20 kHz, but of course there exist waves below or over that range. Cats and dogs can hear higher frequencies than humans. Frequencies below 20 Hz are infrasound. Some mechanical sound or human biological sound belong to this area. Frequencies above 20 kHz are called ultrasonic waves. Our acoustic sensors can recognize a wide range of frequencies from several Hz to 100 kHz. Some mechanical sounds are ultrasound that we can't hear. The sound includes the friction noise when parts are rubbed, the contact noise when parts collide, and the vibration noise of machines. We take advantage of these sensor technologies for diagnosis, prediction, and judgment of non-defective products. We are also trying to correct human biological sounds with an electronic stethoscope and use them for diagnosis. Our acoustic sensor can collect all of these sounds. Now let's move on to the products we are developing. The chart on the upper left shows the timing when the motor failure prediction signal comes out. The horizontal axis is time. This figure shows what you can see from starting operation to total malfunction. If you keep the motor running, ultrasonic waves will be generated after a certain time. Next, vibrations will appear. Third, humans can hear sounds. And fourth, heat is generated. and at the end, smoke comes out and it breaks down. These are phenomena that occur sooner or later when the motor is kept running. Then, when the repairment or part replacement should be done generally, I think there are two main timings. One is when it breaks, the other is regular replacement. Periodic replacement is adopted for large equipment and machines that can cause a great damage if it's stopped. However, it is a waste to replace parts before they break down, so in many cases, they are not replaced until they break. Therefore, it is necessary to catch a sign at a relatively early stage. Our acoustic sensor can detect signs at an early stage. The picture on the right is an experiment where an acoustic sensor is attached to the motor with bond. The below shows the result of an acceleration test in which the motor was operated until it broke. The horizontal axis is time, the vertical axis is the frequency. The color indicates the volume of that frequency. When this color turns red, it means the sound becomes louder. A is normal. There is almost no sound. B shows the motor is working right. In addition, a lot of external noise is contained below 20 Hz. When it reaches C, ultrasonic waves are generated. If it continues to work further, it will be under E condition and will stop at the end. Since ultrasonic waves appear first this way, it is said that detecting sound with an acoustic sensor is useful for early warning. We have started developing and selling acoustic sensors for this purpose. The second example is a noisy workplace uniform. This system contributes to improve communication in a noisy workplace. In a noisy workplace, conversations may be very difficult due to the loud noise of machines. And the people who work in such an environment are required to wear earplugs from a safety standpoint. There is a need for a system that enables smooth conversations even in such situations. To achieve this, we are prototyping a uniform that combines our microphone and conductive fibers from Nisshinbo textiles. First, we correct the sound with our microphone. Next, the data is processed by audio signal processing to cancel the noise. Then, the noise-cancelled data is sent wirelessly to the other. Data communication within the uniform is made of conductive fibers. As you can see, the combination of microphones and conductive fibers creates an easy-to-use communication system. This can be applied to vital sensing too. That covers everything. Thank you for listening. Now we would like to answer questions you might have.
Yeah, thank you very much, Fujiwara-san, for sharing. And now I guess I'd like to dive into the fireside chat with Fujiwara-san and also with Fuji-san. And again, I think all the questions that have started to be asked, whether it's over the Q&A chat or over the chat panel, we'll be answering them later during the Q&A session. So first I'll dive down to Fuji-san. Maybe I'll start by asking you, the application of the audio technology and and by extension, the sound chips can be used in many ways. So is there a reason why Nisshinbo has a preference for health tech and for security?
Thank you, Jeremy. As I mentioned some about in the company introduction earlier, Nisshinbo's corporate philosophy and value pursue realization of safe and secure society for all people. Unlike such as advanced traffic systems and weather radar, they are also our product as well. But NIMS microphone is the sensor that can focus on more individuals or smaller groups due to its characteristics, small and affordable price. That's why we choose these two fields for our first Open Innovation Challenge this time. Therefore, if startups seek better lives for all people, we are in the same direction, and I would like them to come up with various ideas other than healthcare and security.
So I guess it's not just healthcare and security, but also other types of industries. And I think earlier Fujiwara-san was sharing a lot about the different types of sound chips and more about the sound chip and many different sample devices that Nisshinbo can offer to both startups and SMEs. I think some of them are a lot more relevant to this challenge, especially for the vital sensor and the acoustic sensor. So sensor number 3 and sensor number 4. So for myself, where I come from a non-technical background, at least non-technical in this area, so from a non-technical person's perspective in this area, when it comes to the vital sensor and acoustic sensor number 3 and 4, how easy is it to utilize and use these different devices? Yeah, maybe Fujiwara-san, maybe you can share what are your thoughts to the vital sensor and acoustic sensor? How easy is it to utilize, and yeah, how is it, yeah, and to use it also?
Hi. 入れました。それを入れました、チャットで。入れます。今これから通訳します。Okay, いいですか、じゃあ。はい。Okay, the reason why it's easy, the number 3 and number 4 is easier than the other type of sensors or chips is because it's already packaged. Whereas, for example, if you start out with number 1, then you would have to start developing the circuitry from scratch to be able to use this module chip. And that's the main reason why 3 and 4 are probably easy to apply.
And actually, with Fujiwara-san, I think during our discussion, I know you didn't share it this time during this presentation, but I heard that Nisshinbo is also doing some audio visualization. If it's convenient for you, is it okay to share more about this audio visualization? Maybe if you have some slides, is it okay to show what it is and how it will look like? Yeah, for audiences also do know that Fujiwara-san is also talking through a translator. So that's why there are some lags in between our communication also. But during Q&A, don't worry, we will definitely be answering all the questions.
説明するので、少しラグタイムが出ることを皆様ご承知くださいということをおっしゃってます。はい。The main purpose of audio visualization is, first of all, to convert the sound signals into a two-dimensional diagram. This makes it much more easier for both human beings as well as AI to analyze and utilize that data once it is two-dimensional.
Okay, and is it possible if you have if it's not too troublesome, if you have any pictures of the audio visualization, is it just show it?
Okay, could you wait a minute because we'll bring it up for you.
Okay, sure.
それを出して、それで画面共有で。
それの。それ出せばいい。 で、下がこれですね。これで、共有。
はい、共有。
で、これが音です。
So those are the sound. That's the sound wave.
Okay.
Do you see the diagram?
Yeah,
Because
I
we're
can
sharing the
see it.
screen. 見えるっていうことです。はい。
これが生音で、これ FFT で実際に図にしたのがこの種類になります。
So that's the raw audio waves that has been, and then you see the frequency underneath that, and that has been converted to a two-dimensional diagram, which you see at the bottom of this, bottom, I guess, right-hand side.
Mm.
That's the two-dimensional diagram.
So, yeah, so based on that, basically you extract it, you make it into a visualized picture. And I
ですか
think
らこう見える形の、図式化したっていうことですね。Yes.
And I think the bigger question would be, what kind of value can we get out of this audio visualization then?
で、これを図式化するということの価値っていうのは、どういう価値が生まれるんでしょうか。
まず一つは、まず AI に書きやすい。で判断しやすいと。もう一つは今このまま音をクラウドに上げるとデータ量が非常に多くなるんですけど、それが少なく済むと。で、センサーの近くで、判断ができるという価値が出る。
Okay, so the value is, first of all, it's much easier for the AI to analyze the inputted data because it's two-dimensional. So that's the first value. The second value is if you try to have an AI run through these sound waves, then you have to put the data on the cloud, right? And then the data itself is so voluminous, heavy, that it's too much data. But this actually reduces the volume of data. That's the second value.
Yeah, definitely makes a lot of sense. And yeah, thanks for sharing a lot about this audio visualization and the value of using it. But I think as someone who's living in Singapore, we all know that right now we are in a COVID world where travel is actually quite limited. So I mean, I understand that Fujiwara-san is in Japan. So
今ですね、コロナの環境下においてですね、日本にいらっしゃいますよね。そうすると、Okay, go ahead.
So I think the bigger question I have then is, can Nisshinbo help to support in the prototyping with startups or companies?
こういうですね、スタートアップの企業が試作品を生産するときに、きちっとサポートしていただけるのかどうか、このコロナの環境下においてですよ。
はいはい。できます。
Yes.
私どもの方は、シンガポールの事務所を通じて、サポートしていくというふうに考えています。で、私の方の技術、ものは日本で作って、それをシンガポールの事務所で作って、シンガポールの事務所の方からお客さんの方に出すと。
出していくと。はい。Okay. Yes, even under the COVID environment, we have Nisshinbo Singapore, which will be helping our startups. The sensors itself, the model chips and the sensors itself will be manufactured here in Japan. That will be then shipped out to Nisshinbo Singapore, where the employees there will be able to support the startups.
Okay, great. Thanks very much for sharing this. Next, perhaps I'll go more into the partnership side with Nisshinbo now. And maybe Uji-san, I'll ask you, how will the partnership work between Nisshinbo and the startups?
Thank you, Jeremy. The first step is entering into NDA with each startup. And after that, we will have a deep discussion to explore more about implementation of ideas. And as mentioned before, earlier, Fujiwara-san mentioned earlier, both R&D team and business development will be involved in this discussion.
Mm.
And technical support is in making prototype for POC to test their business model. We will mainly provide from R&D team.
So I hear that the entire process, there's quite a bit of support here, but maybe is there any other types of support that Nisshinbo will also plan to provide the startups beyond doing a POC and all of this?
Yes, in terms of sound, New Japan Radio has expertise and solid track record. In particular, we can provide various advice as an expert for sound signal processing. We may also be able to support using our mechanical equipment and resources needed to evaluate prototype or product. It depends on the actual number, but we may provide the chips for free, maximum 2 pieces for each POC.
Okay, fair enough. And I think that in the way this entire innovation challenge has been designed, or at least the way it appears, is that there's going to be 3 cash prize winners. But I think the bigger question is are you actually open? Is Nisshinbo actually limiting the partnership to only 3 startups, or are you open to working with more?
Yes, the prize money will be given to the top 3 companies and priority of POC discussion as well. However, other than the 3, there may be companies have backgrounds that is going well with our technology. So in this challenge, we welcome all unique ideas, and it is just a tool, but combining location information with sound might be interesting. I mean, data from GPS and sound from sound chip. So we have been focusing on manufacturing and achieving reasonable prices for over many years because we are a very old company. But therefore, we are hoping to challenge actively future-oriented ideas that will contribute to future society.
Okay. Yeah, thanks very much, Fujiwara-san, as well as Fuji-san, for this very quick fireside chat. I think right now we just open the floors to the Q&A session. Of course, if you have any questions, just feel free to type it out. My colleague Rebecca from ASG will be moderating it. Feel free to also scan the QR code or to check out the website below at nisshinbochallenge.com. You can find out more about the challenge and to also register and fill in your particulars and to answer the questions there to sign up as one of the participants of this innovation challenge. Yeah. So yeah, Rebecca, hit it off. If you have any questions, we will start it off from there.
Hi. So yeah, we have one question from the ground. So the question is the non-contact sensor capable of detecting human body vital signs like pulse rate and breathing rate?
Yeah, maybe we'll ask Nisshinbo for this. Is it possible?
Yes, so can I answer from Nisshinbo, Singapore? Thank you for the question. And exactly, the sensor you saw in the slide, the non-contactive sensor cannot detect pulse rate and breathing rate. Yes, actually, but in terms of other technology, for instance, radar, we have a 24 gigahertz radar and monitoring the patient that might be able to monitor patient condition such as respiratory rate and heart rate. Am I answering the question? Is it okay?
Of course, if you need any more clarification, just continue to let us know. Yeah.
Okay, so we have another question. How much time do we have for the challenge?
Okay, so the challenge closes, I think, on the 26th of this month, if I'm not wrong. So the challenge should close on the 26th of this month. Just do sign up as soon as possible. and then we'll be looking through the different applicants, and then we'll make a decision by 2nd of April, and we'll have a presentation by the selected applicants on the 12th of April. So that's the entire process. Yeah, that's about it. And our post-challenge, that's where you start to communicate with Nisshinbo very directly and to sign the NDA, and I think you start to work with them very directly after that.
Okay, we have another question. If a startup is chosen, are we able to receive any sound chips or sound chip devices?
Maybe Fuji-san, I know you have said it earlier, but do say again.
Okay, yes, just I mentioned the sound chip, maximum 2 pieces we are planning, but it depends on the idea of the startup business model. So please discuss with us to the number of chips we can provide.
Okay.
Okay, another question is, can we have the slides later?
Yeah. Okay. Fuji-san and Fujiwara-san, is it okay for you if we share these slides after this?
On my side, no problem to sharing.
From Fujiwara-san, is it okay to share the slides that I have right here to whoever asked for it? Is that okay?
Excuse me, we are not seeing the questions, and and the interpreter has a hard time hearing Rebecca.
Oh, okay.
So please repeat the question.
Yeah, so basically they were asking, is it okay for the slides to be shared from Fujiwara side, the slides that you had used for this presentation? Is it okay for us to share?
OK、このですね、スライドはいわゆるプレゼンテーションに使ったスライドを社内とか他社と共有していいでしょうかということです。これが参加者からの質問です。藤原さんのスライド OK ですか？はい。It's all right to share the slide.
Okay, Ken. Yeah, definitely we'll share these slides after this.
OK、でその後に皆さんに配布させていただきます。OK。24ギガヘルツレーダーが人間のバイタルサインを検知できるということであれば、それに関してもう少し詳しくお聞かせいただけないでしょうかって。
これはですね、シンガポールの方で。
Could Nisshinbo on the Singapore side answer this question, please?
Thank you for the question. Yes, we have the prototype, just prototype for 24 gigahertz radar, and now we are developing for use case utilizing for the patient monitoring. So if you are interested in that technology of that product, please let us know in later. I can share more about the radar with you.
Okay, so we have another question. Will Nisshinbo be taking any IP if we were to do a joint R&D collaboration?
Yeah, maybe this one I'll target to Fuji-san for this.
Yes, it depends on our nature of IP and how much contribution from each party, but we may claim IP or equity because it will happen from joint R&D collaboration.
Okay. Yeah.
So the next question is it fine to just submit a new concept idea or concept product involving the sensors, or do we need to have an established product?
Okay, I think for this one, generally, we do prefer to work with someone who has already created a company. So that would be one of the things that we're looking at, because we have 4 criteria that we are judging by. So we do prefer if it's already established company. But if it's a new idea and concept where you're planning to build a product, I think that we will not reject it. In fact, we will actually look at it very closely and see if it's something that we can improve in. So it does not need to be an established product.
Okay, so there's an audience who would like to confirm. We just want to confirm that the company owns any IP that comes out of work.
Sorry again?
So there's an attendee
Hmm.
who commented, I read the small print and just want to confirm that the company owns any IP that comes out of work. Please confirm.
Fuji-san, do you have any thoughts to this?
As for the IPs, can you can you wait for a second?
Oh, okay. Fuji-san, I think the question is, Catherine. So do let me know if I interpret this wrongly. So what I seem to understand from the question is if the company will own any IP that comes out of the joint collaboration. Am I correct in this? So if that's the case, Fuji-san has said earlier that basically it really depends on the type of work that's required from Nisshinbo. So if it's something that requires a minimal effort or just a little bit of effort, then I think there's not much to discuss when it comes to IP. It will be fully owned by the startup or the SME. But on the other hand, if it requires a huge amount of collaboration, a large amount of work from Nisshinbo side. So in terms of work, maybe Nisshinbo is doing 50% of the R&D work, or even maybe more, then I think that then they will say, okay, it's fair for us to have a share in the IP.
Thank you, Jeremy. Exactly. Yes.
Yeah. We'll wait for maybe another 5 minutes more for any other questions that can come up before we close this webinar. Yeah.
Okay, we have another question. Roughly how many sound chips are required for a health monitoring wearable device?
I think maybe this one we'll ask Fujiwara-san to answer this one.
Okay. Okay. It really depends on the application, but currently what we are assuming is that if you're developing applications in the area of vital sensors, at least about six sensors is the number that we have in mind right now.
Okay. And specifically, if it's something like an Apple Watch, how many would it require? Something like that.
ブルーチューのようなものは一つか数個でしょうね。
If it's something like an Apple Watch, then between one or a little bit more than one.
Okay. Thanks very much, Fujiwara-san. Any other questions?
Okay, another question. How will we receive the slides? Will you be emailing them to attendees?
Yes,
これです
yes,
ね、
I'll,
スライドをですね、メールしてい
yes,
た
I
だけるん
will
でしょう
send
かと。
slides to all the attendees who have signed up. So we do have your emails, and we will send it to you after this session.
セッション終わりましたらスライドをお送りしますということです。はい、
オフにして。
Okay, we will have about 3 more minutes before we call to a close to this webinar. Again, if any other questions, feel free to ask.
Jeremy? Had better to sharing with Jeremy.
There's someone called Freddie that would like to ask. Freddie, is it okay if you type it out?
Okay, we have a question. How will the device or sound chip be sent to startups?
Yeah, so maybe Fuji-san. So I think the question is, how will you be sending these chips out? Once they win this competition, they're one of the chosen participants. How will you be sending it out to them?
Thank you for the question. We are prepared to export in a Korean service or something like that. Or if the Singapore startup, we can take from Japan and we can this, hand over the chips. If other than Singapore, we can also send by the courier or something like that service.
Okay. I think there's another question from Freddie.
Yeah, so Freddie would like to ask, is it useful for using this chip sensor in fabrication?
Maybe Fujiwara-san, would you like to answer this one? Is it useful, the chip sensor in fabrication? I think earlier in one of your slides, you were talking about how the chips can even be used to detect when a machine would likely spoil or something. But I think I'll leave this question to you. Is it useful for this chip sensor in fabrication?
Application って言ってるのは、いわゆる組み立て工程とか。
そういう例もあります。すでに。
いや、いいですか。There are already existing applications in the area of fabrication. So this chip is already used for fabrication purposes.
Maybe Fujiwara-san, is it okay to elaborate what are they being used for during fabrication?
で、そのこっちの現場で実際どういう場面で使われてるんでしょうか。さっきの予知保全
モーターの、モーターですね。多くはモーターの故障
とか、
はい、あと、ガス管のリークとか。
Okay, for example, we gave you the example of how the sensor predictively predicts the failure of a machine. But other than that, for example, it monitors the leaks on gas pipes. That's another application.
Okay, thanks very much, Fujiwara-san. Freddie, if there's any industry you're looking at specifically, just do let us know. So I think we can answer it more specifically for you also.
で、メールで追加の質問させていただいてもよろしいですか、はい、これからやり取りさせていただいてもよろしいですかっていう質問なんですよね。大丈夫です。
So the next question is, if necessary, can we send you more questions by mail during the challenge? How do we stay in contact?
期間中にメールで連絡をさせていただいてもよろしいでしょうか。いろいろな質問させていただいてもよろしいでしょうか。というのが質問です。
Yeah, so definitely you can always keep in contact with us. If any questions, just go to the website. There is a form there to fill in, and mainly because we do not want bots, basically Google bots and other bots to take our emails and be spammed with. So we would prefer if you just go to the website and you can basically email any questions that you have to us, and we will reply to you as soon as possible. If it's something that's more challenged and something that's more general, Ace will answer it. If it's something more technical, that's the part where we will get either Fuji-san or we get Fujiwara-san to come in to answer those questions. But just in case, I will type in my email and Rebecca's email into the chat box. Yeah, just do not spam us with random emails. Yeah. So feel free to direct any emails to either myself or to Rebecca for any question you have about this challenge. If there are things that are a lot more technical, we will be bringing Nisshinbo to answer it. And if need be, also to have even a separate small meeting if required also. Okay, I think that calls to the end of today's webinar. Thank you very much, everyone, for joining in. We really do appreciate your time. And if you have any other questions, if you have any other queries, just feel free to drop myself or Rebecca an email. And we look forward to your participation in this Nisshinbo challenge. If you know anyone else that's also a fit for this challenge, we will really welcome them to be part of it. And again, do note that as Fuji-san has said, we are not limiting the winners to only 3 people. In fact, Nisshinbo wants to collaborate with as many people as possible. Yeah, so I think that's all. Thank you very much, and we look forward to seeing you on the pitch day itself. Thank you.